problems on the Turing machine, and after solving 10 designing problems, now we will cover the topic formal definition of Turing machine. So as in the very first lecture we said that the Turing machine is the most powerful as compared to other automata. Mile or FSM with output, you can say FMA all. So this is the relation we have shown here in terms of power. Okay, this is more powerful. Now for PDA, we have seen that, let me zoom a bit. PDA is the FA which has got memory, and that is in the form of stack. So here I hope you people remember by now, and you can visualize that Turing machine is a tape along with FA. So here we will represent that Turing machine is nothing but FA and memory in the form of tape. Again, why we say that it has got more power? Because finite control, which is controlling the read-write head, can move one cell to the left as well as one cell to the right, and it can also modify the content of tape itself. And that's why we say that Turing machine is more powerful as compared to other FAs. And Turing machine is nothing but FA with memory in the form of tape with finite control, capable of reading, writing and modifying the tape symbols. So here, as you know that FA has got 5 tuples: Q summation del, Q0 and F. Let me copy. These are the symbols. Now, when you say this FA is represented by capital M in general, most common notation. When you say tape is also in picture, then along with tape you got tape symbols. Why tape symbols are different than this summation or sigma input symbols? Because if you consider previous example itself, we have seen that input symbols are, say, left and right parenthesis. Capital B is also considered as input symbol, but the tape symbols or the input symbols are getting modified by these additional symbols. So they are representing tape symbols. So here sigma will have left and right parenthesis, whereas tape symbol will have star and capital B. If you consider previous example, ninth example, for binary number, summation or sigma or alphabet will have 0 and 1, whereas tape symbols we are using here are also same. Unlike the 10th wala problem wherein star is used to replace left and right parenthesis, here 0 is being replaced by 0, 1 by 1 very first and then complementing. So tape symbols are 0, 1, B. So likewise you got different, in some cases, sigma and different tape symbol. So new addition here is, in this definition, is related to tape symbol. So that is represented by gamma. Capital gamma is the symbol which looks like this, and then blank cell which is represented using capital B. So now Turing machine will be these 5 plus these 2 tuples. So formal definition of Turing machine will say that TM is a 7-tuple machine presented let me copy the complete represented as M equal to Q summation del Q0 F B and gamma, where by now everyone knows what this sigma means. Finite set of input symbols. Q is finite set of states. Q0 is initial state. Capital F is finite set of final state or states. Capital B is blank cell, and this gamma, this is called as capital gamma. So we will specifically write here. Rest of the things you know. This is finite set of symbols. So out of 7, we have talked about 6 tuples. The remaining is this mapping function. Let me copy this symbol. Now, regarding this mapping function, again we will go to the previous sum. Here, if you refer any of the say transition table entry, what this transition table entry says, or rather this transition table says that this is your current state, this is the current symbol you are processing, and you are getting output as next state, symbol on tape, and action. So this is what your transition function for Turing machine is defining. What it is giving you? Mapping is current state, comma, current input symbol. It is giving you what? Giving you next state. It gives you modified or unmodified tape symbol. Simply you can say tape symbol and any of the action, either move to left or to right or do nothing. And that's why current state is represented by Q. Current symbol is represented by, let me insert summation symbol. If it's there, what I need to copy sigma. This is giving you, you should be able to explain each and every part of this transition function. It's giving you next state, which is a part of Q. Modified tape symbols. Here you should write this gamma and then Now again, if you think upon this, when you write this as summation, whether only summation you are using for defining the transition? No, sometimes the tape symbols are also acting as the current symbol to be processed. Like in this example, sigma will have left and right parenthesis. If we consider the previous example, sigma and then gamma will have values round bracket left, round bracket right, whereas this will have values so now when you enter the data in transition table, if you consider this here, the current state is Q1, current input symbol is star, and whereas star belongs to this gamma. So this is properly written as symbol, or it can be the union of input symbol and tape symbols. Again, you will find some of the transitions are also defined on blank. So this should be modified likewise. Here also you will find that sometimes when you say 0 is kept as 0, this bracket is kept as left bracket is kept as left bracket only. So here also you can modify it gamma as gamma union sigma. And later modifications. I hope the transition of this thing till this modification is understood. You will be able to understand this thing only if at least one transition diagram you have drawn on yourself and not copied as it is. So you will find that the transitions are defined on the sigma symbols as well as gamma symbols, and that's why we have written here current input symbol represented by sigma union gamma union blank, because the transitions are defined on blank as well as star as well as left right bracket symbols. Rest of the 6 tuples we have already discussed. So this will constitute the definition, formal definition of Turing machine. Again we will repeat. Turing machine is the 7 tuple machine represented as m equal to these 7 tuples, where you are supposed to write description of each and every tuple, like Q is finite set of states, sigma is finite set of input symbol likewise, and then this is must. Mapping of transition function is must. Then, as with all other automata, you must explain this with the help of one diagram. Here you will say that this is the initial state. Having a self loop, you can have some input symbols. And likewise, you can have the simplest diagram, any random diagram, which is simply showing what will be the content of each and every symbol from the formal definition. So here Q will have the value Q0, Q1 and halt. Capital F will have value halt, which is set of final state. Q0 will be Q0 itself. Then sigma. Likewise, you should be able to write the values of each and every tuple. For writing sigma, you must take some, say if it is 0, let it be 0, move to R. Randomly you are writing this. You are changing the state. If 1 is encountered, you are saying let it be 1, move to R. And then, or you can say if 1 is there, you are changing it to 0 and you are moving to, and finally if B is encountered, let it be B, do nothing. Likewise. So here input symbols are 0 and 1. Blank is represented by capital B only, whereas gamma here is representing you can say 0 1 B. If in case you have X represented by 0 represented by X, 1 represented by Y, then instead of 0 1 you will have X, capitally लिया है हमने, X and Y here. So now you will find that the union of this will be 0 1 X Y B. You may or you can exclude B from here if you have written this to be the union of 3. So it will give you 0 1 X Y B. If B is excluded from here, it is understood that you are including it in tape symbol gamma, because B will always be there even if the tape is blank. Capital B is going to be always there. Just why this tuple is included, how you are representing that capital B. In some books you may find that small b is used or hash is used for blank. So just to differentiate small b as in input symbol, we are using capital B. And hash generally we are using for separating two subparts of the string. What else is 6 tuples we have listed? Then remains the transition function, which will be defined likewise. So you should list the transition function also likewise. So this part will now, till this, from this point till this, it will complete the formal definition of Turing machine. with example. You should always give example, visual representation whenever you are writing the definition of any of the automata. And now you will find that with each and every automata, this transition function or mapping of transition function or definition of transition function changes. And that is the main differentiating point when you compare different automata. So if you are comparing PDA with Turing machine, the main difference you will find is because both of them are 7-tuple machines. The main difference is regarding the mapping of transition function. So carefully you need to note down the or rattai karna hai, learn karna hai. If it is understood, you don't need to mug it. If there is confusion, you need to mug it for each and every automata, because the difference between these automata is always asked, and especially the difference between DFA and NFA. In that case also the mapping of transition function differs. Even you consider the case of NFA and NFA with epsilon, the transition function differs. Difference is very minor of 1 or 2 symbols, but the function is not same. So after this, we'll start with our example number 11 for the designing of Turing machine. And that example number 11 says that, let me copy this example. The statement, it says that design Turing machine to perform following operation. What operation it is expecting? Initially, the tape contains 2 finite blocks of ones separated by finite block of blanks. Machine should delete block of blanks between 2 block of ones. So now understanding and visual representation of this sum is important before you start with the designing part. Unless and until the operation is understood, you won't be able to design the proper Turing machine for this. So it says that initially tape contains 2 finite blocks of ones separated by finite block of blanks. So we will start with input on tape as always, which gives you visual representation. So if I say I got this block 1 consists of 2 ones, then I got a block of blank which consists of 4 blanks, and then I got block B2 which consists of 3 ones. So this is the visual representation of input tape for this sum. Take a minute, read the problem statement. What it says: initially tape contains 2 finite blocks of ones. So B1, B2 are your 2 finite blocks of ones. They are separated by finite block of blanks. Machine should delete block of blanks between 2 blocks of ones. So what we are expecting, output on tape we will be solving this sum likewise. So this is what is expected. No more blanks are there between B1 and B2. So this is your B1 and this is your B2 and contiguous spaces. So try to think about this, because when you say designing of Turing machine, it's a mechanical operation. You should think this tape is infinite in length. At a time, only one cell is visible. Abhi, whatever I have drawn, the whole tape is like visible to you with the total. You can also count the total number of ones in B1, total number of ones in B2. But the real life scenario is tape is infinite. You are not aware how many ones are there in B1, how many ones are there in B2, and still you need to remove. You don't know how many blanks are there in between them, and still you are supposed to remove the block of blank. The only thing you know that number of ones are finite and in between blanks are also finite. So mechanically, if you are supposed to do this, how you will be doing? Take a minute, try to visualize. कैसे visualize करना है आपको? Suppose consider the tape is laid on a road from your college, Bharati Engineering, till say CST. There is a road, straight road, and tape is laid on that. You don't know how many kilometers it is, might be say 35-40 kilometers का tape है, and you don't know how many blocks are there, how many ones are there in one block, how many ones are there, and you got a bike with you to remove the blank and shift these ones in between CST and Bharati Vidyapit. So how you will be doing that? Try to think. So the operation we will represent using say arrows. Let me copy this one more time. And how we will represent manual shifting. ये वाला one we are shifting here. Next वाला one we are shifting here. So when you are doing this shift operation, what you are left with? ये B हो जाएगा. This one occupies this cell. Next is this is converted to B. It is shifted here. Again you are checking. Let me explain one more time. When you very first leftmost one you have picked, that cell is blank. It is transferred to first B encountered on right hand side. Right? ये वाला वन यहाँ पे डाल दिया. इसके बाद it will check whether one more blank is there. If yes, it will go to this point. It will pick this one. If this one is picked, the blank remains here. This one is shifted here. Consider one ka card is picked from here and is now kept in this block. Again it will check whether one is there, whether blank is there. and again you do the shifting. Now shift. Likewise. इसके लिए you are supposed to design the Turing machine. Once you shift it here, what will be the scenario? Pick this one, so B will remain here. This B is placed here. This one is placed here. Check whether blank is there. If yes, pick this one, B remains here. Check whether blank is there. No. So blank is not there means now both the blocks are at contiguous location. Continuous memory location or contiguous location. No blank is between them. So this will be your accepting condition, that whenever you check for B on the right hand side, you don't get B, rather you find 1. So now both the blocks are in the continuous memory space, contiguous location. So in words, how you will write this? Take a minute, think about this. In words, now you need to write the logic in bulleted form. Visual representation आपने दिखा दिया. Now description of this is the logic for building your Turing machine. What you are doing? I hope I am unmuted. Yes. So what is the logic in bulleted format? Pick keep moving to right. When you say pick leftmost one, after picking that one, what is left in this cell? Blank. So it is represented by B. Pick leftmost one, keep moving to right. One in the first blank cell found while moving to right. It's right to check whether blank cells are or blank cell is there, needs to be filled with. If B is there, keep moving to left to pick leftmost one and above. Now here, how you will get to know that it is the leftmost one? Your aim is to pick the leftmost one. अभी यहाँ पे क्या हो रहा है? Consider this is B, this is 1. What you have done at this point? यहाँ का 1 आपने इधर शिफ्ट कर दिया. So out of 4 blank, 1 is occupied, 3 blanks you are left with. And this 1 is picked and shifted, so this is blank. Next, you need to shift this 1. So what you are doing first, you are checking to its right whether blank is there which needs to be filled with 1. If blank is there, keep moving to left. Keep moving to left. If B is there, keep moving to left to pick the leftmost one. So what you will do, you will keep moving to left. How you will know that you need to pick this one? Leftmost one is the one who has B to its left. This cannot be leftmost one because there is no B to its left. This is the one which is acting as leftmost here because B is there. So you will keep moving to left unless and until B is encountered. As soon as B is encountered, you will go to its right. यहाँ से you will pick this one and shift here. So as this one is picked, B remains and it is placed here. How you will get to know this B? You will keep moving to the right side unless and until you find right to check whether keep moving to right. Put 1 in the first B cell found while moving to right. So this is the first B you found while moving to right from this location. So you are putting 1 here. I hope this is understood. Next इसमें you are doing this thing, right? ये हमने remove किया. Accepting condition, what you are getting? यहाँ पे when you say go to its right to check whether blank cell is there which needs to be filled with 1. So go to its right to check whether blank cell is there. But no blank and 1 is found. So it means it's a accepting condition. I hope this is understood. यहाँ पे कुछ confusion है, कुछ doubt है. So now we will design Turing machine. To 0. क्या करना है आपको? Pick the leftmost one. Obviously it is pointing to this leftmost one. यहाँ पे when you start processing you are in Q0 and it is pointing to this one. So Q0 में you will pick this one. So if this is picked, it becomes blank. You don't need to have this on looping. So we are having this dedicated line for it. So it says that यहाँ से करते हैं, if it is 1, make it blank and move to R. Description maybe we have written the same thing. Pick leftmost one, keep moving to right. Keep moving to right till you find first B. So keep moving to right में you may find n number of ones in B1. So all those ones you need to skip. So if it is 1, let it be 1, move to R. यहाँ पे 1 है, ये आपने पिक किया, this turns blank and you are moving to right. This should be skipped. You are in Q1 and this should be skipped. and you are moving to right. So 1 should be 1, keep moving to right. As soon as you find first blank, it should be turned to 1 and you need to move to its right to check more blank is there. So यहाँ पे you have added 1 and you are keeping head to its right. So this blank is turned to 1, you are moving to right and state क्या है आपका Q2 में B को 1 किया आपने, you are moving to right. If blank is there, let it be blank, move to its left to pick the leftmost one. You say if blank is there, let it be blank, move to its left. And then repeat the process. So यहाँ पे आना है आपको. Using what transition will come here? If it is B, let it be B, come here. So instead of this, we will add it here. If it is B, let it be B, come to Q0. If it is B, let it be B, come to Q0. Whatever one is there, you need to skip until you find B. So whether you can add it here, if it is 1, skip it, move to left, or you should be doing it from here only. By now, this is 11th problem. So you should be able to decide whether this is suitable. If it is blank, let it be blank, move to its left. Left में it's quite possible that you will encounter n number of ones. So all these ones should be kept 1. Keep moving to left. Unless and until you encounter blank, which should be kept blank and you need to move to its right. So क्या हो रहा है अभी? When you say this, you are in Q3. In Q3, from Q2, B is kept as B. You are moving to left, you are in Q3. So left में you encountered 1. So in Q3, now pass 2. In Q3, you encountered 1. 1 should be kept as 1. Move to left. Again in Q3, you still remain in Q3. 1 should be kept as 1. Moving to left. In Q3, you encountered B. So B should be kept as B. Move to its right. Now you are sure that this is leftmost one. So you are in Q1. As soon as you encounter Q1, you pick that. So blank is left and you keep moving to Right. Right में if 1 is there, skip it. You still in Q1. Q1 में you encountered B, that should be replaced with 1. And move to right, you are in Q2. Q2 में you encountered B, let it be B, move to its left. You are in Q3. Q3 में you encountered 1, let it be 1, move to left. Q3 में you encountered 1, let it be 1, move to left. Q3 में you encountered B, let it be B, move to its right. You are in Q0 now. Q0 में you encountered 1, make it blank and move to R. You are in Q1. Q1 में you encountered 1, let it be 1, stay in Q1, move to R. Q1 में you encountered B, replace it with 1, move to R. You are in Q2. Q2 में you encountered B, let it be B, move to its left. You are in Q3. Q3 में you encountered 1, keep moving to left until B is found. As soon as B is found, let it be B, move to its R. You are in Q0. Q0 में you encountered 1, pick it. So this becomes E. Move to R. Q1 में you encountered 1, skip it, move to R. Q1 में you encountered B, replace it with 1, move to R. You are in Q2. Q2 में you are supposed to encounter now B, but you encountered 1. It means that no more blank space are there in between two blocks. So you encountered this 1. So let it be 1, perform no action, and this is your accepting condition. So you halt. So you say here halt. So this will be your complete Turing machine designing for the given operation. Take now one more random string and try to process it using this Turing machine. Now consider here the example that we have taken a block of blanks of 4, more number of blanks than this number of ones in B1. So you are required to perform it repeatedly. If reverse is the case, if there are 4 ones and 2 blanks, then you try to process this string using this design. Take a minute, do it with the pen and paper. Mics are provided. If you have any doubt, you should ask. I hope you are able to trace the other string. If any doubt, you should ask. Let me share the attendance link with you. The attendance link is copied in chat. It's active. And whether anyone, if you felt कि हाँ किसी transition definition में there is गड़बड़ or you are not convinced, you should tell that also, so that we can discuss कि why it is been connected here. अभी in the same example, what I told you, that instead of having this B/BL, if you connect it to Q0, so what will happen? So that case we have discussed. So likewise, there might be any sort of doubt कि why we are taking some extra state, or why less number of states are taken, whether we can expand it more. Can we have the total, abhi to 5 states are there, can we have the 6 states, and what for that should be taken likewise. So if you have any such sort of doubt, what you can do is you can try to connect it here and then try to trace a valid string, and just check whether it is reaching this fault state or accepting state from the initial Q0. So somewhere you will find that it is getting stuck to non-accepting state. That might be the case, and again the more number of states can always be added. It won't be the optimized Turing machine. Repetition might be there, but still it may work fine. But if we say that such kind of design requires minimum 5 states, so if you are designing it in the 4 states, it means something is wrong. That for say 2-3 strings, one or two transition definitions or the operations will go wrong. So if minimum number of states required are 5, it should be 5 only. You can have 6, 7. That will be the repetition, or it may, like in case of programming, say the simplest example is what, addition of two numbers. So you can have only two variables declared and result will be printed as a plus b. But some of the students will take third variable also, c. They will write c equal to a plus b and then they will print c. So both of them are giving you the results, but one is optimized, other is not. So it may but the minimum two number of variables are required here to store the two different values. So likewise, I meant here that if 5 minimum number of states are required, so the designing can be done with 5 or more states, but it should not be done with less number of states. I hope you got my point. If there is any doubt, you should ask. If no doubt, you should switch the lecture.